Okay, writing vectors in terms of magnitude and direction. Okay, it says the jet stream is blowing at 60 miles per hour in the direction of north 45 degrees east. Express its velocity as a vector in terms of I and j. So, I have a wind blowing north 45 degrees east. So I start off looking north and then I swing open 45 degrees east. So that means, what's this angle here? What's the angle of my vector? 45, yeah. Your angle of your vector is always going to be in the standard position. So it's going to start at the positive x-axis. So I'm going to swing open this way. Okay, so it says it's blowing at 60 miles per hour. So my length of my magnitude, or my length of my vector or my magnitude is going to be 60 miles per hour. And I know my angle is 45 degrees because we just figured that out. It's not because this is 45 degrees. It's because this angle here is 45 degrees. It's just a coincidence that they're the same at this point. Okay, so if I want to write in terms of I and j, I have to use that trick to find my a and b. Remember, a is the horizontal component, so I take my magnitude and multiply by the cosine of my angle. The cosine of 45 is the square root of 2 over 2, and then 60 times the square root of 2 over 2. That would give me 30 square roots of 2, because I can cross off the 2 with the 60 and make that a 30. For my vertical component b, I'm going to take my magnitude times the sine of my angle, which is 45 degrees. So that's the sine of 45 degrees is the square root of 2 over 2. So I'm going to take 60 times the square root of 2 over 2. And again, I'll get 30 square root of 2. So if I want to write this now in ij form, I'm going to have vector v is 30 square root of 2i plus 30 square root of 2j. Everybody okay with that one? Okay. Okay, this one says a quarterback releases a football with a speed of 44 feet per second at an angle of 30 degrees with the horizontal. Angle of 30 degrees with the horizontal means this. 30 degrees with the horizontal. My magnitude is 44 feet per second. And we need to do the same thing. We need to write this vector in terms of I and j. So I know my magnitude is 44 feet per second. And I need to find my a and my b. My a is 44 times cosine of 30 degrees. My b is going to be 44 times sine of 30 degrees. My cosine of 30 degrees is the square root of 3 over 2. So I'm going to have 44 times the square root of 3 over 2, which would be 22 square roots of 3, because I can divide that 2. The sine of 30 degrees is 1/2, so I have 44 times 1/2, which would give me 22. So my vector in ij form is going to be 22 square root of 3i plus 22j. Everybody still doing okay? All right, this next example here is a good one to look at, specifically because everything that we've done so far has been in the first quadrant. We haven't really done much with any of the other quadrants. So it says a vector v is in standard position and makes an angle of 150 with the positive x-axis. So 150 means I'm going to swing open this way. So this is vector v. It has a magnitude of 30. And we want to write v in the form AB with our little arrows and in component form with the ij. So we're going to do the same thing, but now it's in a different quadrant. So what should be negative, the A or the B? If I'm in this quadrant here, yeah, A is my horizontal component. So when I'm in this quadrant here, I should get a negative. So I'm going to take 30 times cosine of 150 degrees. That's going to give me my A, and my B is going to be 30 times sine of 150 degrees. Cosine of 150 is negative square root of 3 over 2. So that's going to be minus 15 square root of 3 when I divide out that 2. Right, take the 30 divided by 2, that gives me a 15. Sine of 150 is a half. So I'm going to take 30 times a half, and I'm going to get positive 15. So in this form, I'm going to have negative 15 square root of 3, 15. If I write it in component form with the ij, it's going to look like this. Negative 15 square root of 3i plus 15j. Everybody good? Okay.